You know what's truly mind-blowing about LS engines? They weren't supposed to be this powerful. It's almost like GM's engineers accidentally created a monster. What started as a simple evolution of their small block V8 ended up becoming one of the most overbuilt and underestimated engine platforms in modern automotive history. Even when left completely stock, factory tune, warranty intact, these engines put down power figures that, just a couple of decades ago, were reserved for full-on race cars. And we're not talking about exotic high-revving overhead cam motors. These are pushrod V8s, a design concept that dates back to the era when color televisions were considered futuristic. Yet somehow, these engines were outperforming modern, high-tech power plants that cost triple the price. If you've never heard about LS engines making too much power, well, here's a fun fact. GM's legal team reportedly had concerns over their dyno results being too high. They feared warranty nightmares, insurance hikes, and potential liability issues if the real numbers got out. When the LS1 debuted in the 1997 Corvette, GM claimed it made 345 horsepower. But when enthusiasts started testing, the truth came out. Most cars were showing between 320 and 330 horsepower at the wheels, which translates to about 380 at the crank. That's a massive difference, and it wasn't a mistake. GM intentionally sandbagged the numbers because they knew this engine was punching far above its weight. What's fascinating is that the LS engine wasn't revolutionary on paper. Many of its core ideas, like a deep skirt block, cross-bolted mains, and 6-bolt main caps, had been around for decades. What made the LS special was how meticulously those ideas were executed. The engineers refined every tiny detail to perfection. The bore spacing, for example, stayed at a conservative 4.4 inches, identical to the classic small block Chevy. That conservative choice allowed for thicker cylinder walls, which in turn made the engine incredibly tolerant to boost. Those thick walls became one of the reasons tuners fell in love with the Ls. It could handle serious power without even cracking open the block. The factory internals were equally impressive. The stock connecting rods in an LS1 can safely support around 900 horsepower. That's from an engine that originally powered a Corvette with a cassette player. The crankshaft, even in its basic nodular iron form, could take 1,000 horsepower if treated right. Later engines use powdered metal rods, considered weaker by some, but even those easily handle 600 horsepower at the wheels. These weren't forged race parts. They were mass-produced factory components built to last, and somehow ended up being stronger than many aftermarket parts from the 1990s. Skeptical? Just visit any drag strip. You'll find countless LS-swapped cars running deep into the tens with stock bottom ends. The truck variants, like the LQ4 and LQ9, are even crazier examples. These 6-liter iron block engines were originally designed for heavy-duty pickups meant to haul cargo and tow trailers. But car guys started bolting on turbo kits, and suddenly these workhorse motors were making over 1,000 horsepower without even opening the engine. No forged pistons, no aftermarket rods, just boost, tuning, and a bit of luck. Even the so-called inferior cathedral port heads flow extremely well from the factory. About 250 CFM, which rivals high-performance race heads from the 1970s. With just a light port job, they can hit 280 CFM, enough airflow to support around 550 horsepower naturally aspirated. The LS6 heads flow even better, pushing 290 CFM with nothing more than a proper valve job. These aren't exotic components, they're emissions-legal, mass-produced heads from vehicles like the Cadillac CTs or a family SUV. GM's engineers had accidentally created cylinder heads so good that even the aftermarket struggled to improve upon them. The intake manifolds tell a similar story. The ugly, plastic-looking truck manifold flows astonishingly well, outperforming many aftermarket intakes from the muscle car era. The LS6 manifold, in particular, became legendary, because it was practically perfect straight from the factory. No porting or modifications required, just bolt it on and enjoy more power. Then there's the Valvetrain. Critics often call pushrod engines old tech, but the LS Valvetrain is a masterclass in precision simplicity. The rockers are shaft-mounted for stability, the pushrods are shorter to reduce flex, and the beehive valve springs are designed to minimize weight and resist valve float at higher RPMs. Stock LS1 springs are good to 6,500 revolutions per minute. LS6 springs can handle 7,000, and LS7 springs? They're happy spinning at 7,200 all day. And remember, these are hydraulic roller setups, not delicate race-spec solids. Even the oiling system is robust. The LS uses a Girotur oil pump, more efficient and reliable than traditional gear pumps. The windage tray looks like something out of a race engine, the oil passages are generously sized, and the PCV system was carefully designed to prevent oil blow-by under boost. It's as if GM's engineers built the Ls with forced induction in mind, even though the production versions weren't turbocharged or supercharged at the time. The combustion chambers also deserve attention. With a 15-degree valve angle and compact 61 CCS chambers on most cathedral port heads, the LS offers great compression and efficient flame travel. It can run happily on regular 87-octane fuel, yet still respond beautifully to premium gas and aggressive timing. The knock sensors are sensitive enough to let the ECU push the timing right to the edge of detonation, safely maximizing performance. And that ECU? It was light years ahead of its time. The LS1's PCM featured wideband O2 sensor support, per-cylinder timing control, and advanced knock detection, all in the late 90s. Tuners quickly realized how much flexibility that gave them. The computer could adjust dynamically, pulling or adding timing as needed to keep the engine safe while making serious power. This wasn't some primitive system from the 1980s. It was modern, adaptive, and incredibly capable. GM's constant internal tug-of-war between marketing, engineering, and legal departments only added to the legend. Marketing wanted big numbers to sell cars. Legal wanted low numbers to avoid lawsuits. And the engineers? They just kept over-delivering. The LS6, officially rated at 405 horsepower, was actually making closer to 450. The LS2 claimed 400, but in reality it produced around 430. The LS3 was rated at 430, but tested near 460. Everyone in the industry knew the numbers were being sandbagged, and so did the insurance companies. Those insurance companies weren't fooled. When a 1,998 Camaro SS was rated at 320 horsepower, they calculated premiums as if it made 380, because that's what their own dynos told them. Everyone knew the truth. GM was downplaying its power figures to protect itself, and car enthusiasts were the ones reaping the rewards. The iron block LS versions deserve their own spotlight because, quite simply, they're almost impossible to destroy. The LQ4 and LQ9, for instance, share nearly identical blueprints, the only real difference being in their pistons, and both can handle nearly any punishment you throw at them. Whether it's boost, nitrous, or high RPM abuse, they just keep going. The strength of these blocks is unreal. Builders are boring them out to 4.125 inches and creating 418 cubic inch monsters that still spin happily to 7,000 revolutions per minute. Sure, the main caps can start to move slightly when you're pushing into the 1,500 horsepower range, but think about that for a second. That's 1,500 horsepower from a truck engine. It's a fair question to ask why other manufacturers haven't managed to replicate this kind of bulletproof performance. Many have tried. The Hemi has similar displacement potential but demands far more aggressive camshafts to make comparable power. Ford's Coyote needs 4 cams and 32 valves just to keep pace. Toyota's 2 ERGSE is a masterpiece in its own right, but it costs nearly 10 times as much to build. While others rely on layers of high-tech engineering, GM solved the problem in the simplest way possible back in 1997 with smart, efficient, and durable design. Even the LS accessory system is a thing of genius. Everything fits tightly together, the belt routing is clean and easy to service, and you can remove individual accessories without disrupting the rest of the system, a concept foreign to most modern European engines. Ditching the power steering pump alone frees up around 15 horsepower. The AC compressor is mounted high to avoid debris, the belt tensioner is rock solid, and every component is positioned with maintenance in mind. It's as if GM's engineers actually considered the mechanics who'd be working on them. Imagine that. The stock exhaust manifolds, often the first part people toss for long tube headers, are surprisingly capable too. They're nearly equal in length, use thick flanges that resist warping, and can easily support around 400 horsepower without choking the engine. Sure, headers are better, but the OEM manifolds aren't the restrictive dead weight people make them out to be. The real bottleneck lies in the catalytic converters, which are some of the most restrictive parts of the entire setup and practically beg to be replaced. Fast forward to today, and LS swaps are everywhere. So common that they've become almost cliché. You'll find them in Miatas, 240 SXs, BMWs, and even Porsches. The engine's compact dimensions, manageable weight, and massive power output make it a perfect fit for nearly anything. Add to that an aftermarket scene with endless support, mountains of data, and plug-and-play solutions, and you've got the ultimate formula for reliable performance. What's even crazier is that GM hasn't stopped improving the architecture. The modern LT series, technically the Gen V evolution of the LS, keeps the same core design but adds direct injection and variable valve timing. The result? Even more power, higher RPM capability, and astonishing fuel efficiency. The LT1 pushes 460 horsepower while delivering around 30 mpg on the highway. The supercharged LT4 produces 650 horsepower reliably, and the LT5, a jaw-dropping 755 horsepower with a factory warranty. The irony is that none of this was GM's original intention. The LS1 was never meant to become a motorsport legend or a 4-digit horsepower platform. It was supposed to be a lighter, more efficient successor to the LT1. No one asked for an engine that would dominate racing for decades or become the go-to swap motor across the world. Yet here we are. In its simplicity, 2 valves per cylinder, a single camshaft, and pushrods, it defies modern complexity while outperforming it. It runs on regular fuel, lasts 200,000 miles, and still makes numbers that humiliate newer, flashier engines. Tuners quickly learned the LS's hidden potential. These engines love ignition timing. The factory tune is conservative for emissions and warranty protection, but add just a few degrees of timing, lean out the fuel slightly, and you'll see power gains of 30 to 40 horsepower instantly. Raise the rev limit by 500 revolutions per minute, and the power curve stretches even further. It's as if GM left horsepower on the table intentionally. They probably did, building in massive safety margins knowing enthusiasts would push the limits. That foresight made the LS the industry benchmark. Every performance engine since has been compared against it. Every swap discussion inevitably includes someone asking, why not just use an else? Because honestly, it's hard to argue with the logic. Why spend tens of thousands building a custom motor when a junkyard Ls and a mild cam can make the same power? Sadly, we may never see another engine like it. Emissions laws, efficiency mandates, and the shift to electric power mean the age of overbuilt pushrod V8s is ending. The LT series might be the last of its kind, a final evolution of a lineage that began in 1955. When it's gone, we'll be left with forced induction 4-cylinders and electric drivetrains. They might be faster, but they'll never have the visceral soul of a cammed L screaming to redline. It's interesting to think how things might have been different if GM had been honest about its true power figures from day one. Would insurance costs have tanked sales? Would regulators have cracked down harder? Maybe. But chances are it wouldn't have mattered. The LS was simply too good to fail. GM accidentally built a race engine and disguised it as a production V8. They underrated it for safety and legal reasons, but the dyno doesn't lie. Every time a stock LS outperforms its claimed rating or a junkyard 5.3 survives 20 pounds of boost, the legend only grows. GM's engineers created a masterpiece of practicality and strength. Every bolt, passage, and casting had purpose. There's no mystery formula or exotic metal involved, just intelligent design and consistent manufacturing. That's what makes the LS unbeatable. Ford fans might argue the Coyote is superior, and Hemi enthusiasts will tout displacement, but when you want cheap, reliable power, the LS stands alone. And that's the beauty of it. Simplicity done perfectly. The LS proves you don't need complexity to make big power. Just solid engineering and smart execution. It's an engine that outperforms its own expectations, embarrasses pricier rivals, and keeps going long after everything else breaks. Even decades later, the LS remains the king of power per dollar, a legacy that no amount of tech can replace.